This is IAT355 Visual Analytics, Lecture 4.3, Visualization Tasks. So once again in this lecture segment, we're focusing on visualization tasks. This time, the framework is presented in Chapter 3 of Tamara Munzner's book, Visualization, Analysis, and Design. And we're going to be focusing on the first major chunk of that chapter, where she speaks of actions and targets. So one of the things that Dr. Munzner talks about in visualization, analysis, and design is in section 3.2, where she encourages the reader to think about tasks abstractly. And so I want to spend a bit of time talking about the role of abstraction in the work that we're going to do throughout the term. Her advice primarily is to not get stuck on domain-specific terms of the problem domain that you might be working with. If you are a visualization designer, or if you are a tool designer, or if you are an analyst yourself of that particular domain. One of the things that she strongly encourages is abstraction, because if you're dealing in abstract terms, you will find yourself being able to sidestep or overcome the language differences that may emerge between different domains of work. And so therefore, her suggestion is to use abstract terms to refer to the kinds of problems that you might be dealing with. And this is a standard approach in computer science and in engineering and mathematics particularly. The idea is to come up with, instead of a list of detailed problems, come up with an abstraction that represents the essence of what those problems are about and solve the problem in the abstract and hopefully work towards a solution that works towards and solves all of the detailed variations of the problem that you might confront. And that's a good approach. However, there's a little problem. One of the drawbacks of thinking about abstractions alone is that your users don't care about your abstractions. They might care to some degree, but they probably care more about their domain's abstractions than they do about the tool's abstractions that you might be interacting with. So one of the things that's required, particularly of IAT people, is the need to speak the language of the user. I view that as absolutely vital, and the primary role that IAT folks are going to play in any organization, being able to do something very important, and that is to translate between the abstract and concrete. And I say between here because it's bidirectional. You need to translate from the abstract to the concrete and from the concrete towards the abstract. There is such a thing as being stuck in the concrete problems and not being able to see complex problems in terms of abstract representations of those problems, and therefore to be able to borrow those solutions of the abstract problems. That can be a drawback if you're trying to solve a new problem in a new domain. Similarly, it's not too productive to get stuck at the abstract level and be unable to transform the abstract problems into concrete solutions. That's a real drawback, and I discourage that. So as we move forward, think about how the abstract and the concrete elements of a problem domain fit together, and how the abstract solutions that we're going to speak of throughout the term can be transformed into the concrete situation that you may be facing from day to day. Particularly in the end of term project, that translation from abstract to concrete might be very important for what you're going to do in your project. So, because Dr. Munzner is focusing on presenting abstractions, she's taking a somewhat top-down, that is to say, from the abstract towards the more detailed, from the broad to the narrow. She's taking a top-down approach. And the idea here, as I've illustrated, is to start with a complex concept, such as, is there a relationship? And then break that complex thing into simpler parts. What variables should we relate? And then keep refining those simpler parts into even simpler parts until you can go no further. There is no further simpler thing. And here's just a detailed example. Keep refining until no further breakdown is possible. And an example of that is to correlate x and y, which are variables taken from the variables that are present in the relationship of the data you're asking questions about, and to have that relationship be illustrated, be visualized with a scatter plot. And this top-down approach is the approach that Munzner takes in Chapter 3. I just wanted to point that out and make it explicit so that you know what's going on. So, Munzner has this idea of actions that take place that are things you do to data and visualization, and these are verbs that you do to the nouns of the situation, which are the actual data that you're faced with. So in this diagram, which is taken from lecture 2.1, you see this chain of transformation, once again, from raw information into a data set that's been transformed by a data transformation into a visual form that has been undergone some form of visual mapping, and towards views that have been subject to view transformations. The actions that Munzner is focusing on are these things here: the data transformations, the visual mappings, the view transformations, and in fact the earlier phase, not quite shown in this diagram, where raw information is selected for processing by this whole pipeline. So the actions that we're going to speak of as we move forward here are really focused on this aspect, the actions that are going to happen on data. So here's figure 3.2, page 46 from Munzner's book, and we have these three categories of actions that she suggests. The first is analyze, in which there are two sub-actions, consume or produce, which we'll explain shortly. And then we have search, which is a more detailed suite of actions that depend on either consuming or producing and flow from the act of wanting to do these at higher level tasks. And then finally, at the lowest level is query. I haven't drawn these from top to bottom because of the aspect ratio of the slides here. But think of this analyze stuff at the top, the search stuff in the middle, and the query stuff at the bottom of an abstraction pyramid. And the analyze thing is the most abstract, and the query is the least abstract, or the most detailed, the most concrete. Okay, let's move forward. So first, let's focus on the consume subset of analyze. So analyzed, pointing at consume, pointing at discover. Discover is a process that we all think of when we're thinking about doing visual analytics. The purpose of doing discovery is to find new knowledge. The act of finding new knowledge, of course, is very important in visual analytics. It's one of the primary things that visual analytics researchers focus on, and that is you have a collection of data, and what you would like to do is to find out what is going on in that data and explore an existing question or come up with new questions or hypotheses. And to verify those hypotheses, to validate those hypotheses, and perhaps through examining the data, generate new hypotheses. And generally speaking, the tool designer, if you're in the role of a tool designer, doesn't know in advance what the user will need to see. And of course, what that means is that this high-level task of discover is something that, if you're building a tool to enable discovery, you need to have lots of facilities that enable the examination of data. This slide, of course, because it's at the top abstract level, doesn't speak to the details of what to do here. Next is present. Often it's assumed, particularly in some parts of the visual analytics world, that it's all about discovery, but something that's equally important for visual analytics is, as a process of analysis, what you need to be able to do is to take an analysis and present that analysis to someone else. So the text here says, present to someone else something the analyst already understands. Whereas the analysis thing on the previous slide was about discovering things, here is showing that discovery to someone else, or to someone else. And the job here is a little bit different. It's not just to think about things, but to communicate that thing, to persuade, to make an argument, to tell a story. And you often see the present part of visual analytics in the media. And so here is a snapshot of the United States and what's going on in this map. This is from a number of years ago. The blue tones for counties in the states in the USA indicate folks who are doing well economically, and the strongest orange here indicates counties in the USA where the populace is doing poorly or doing worse than previous years in terms of economics. So this thing is presenting a geographic distribution of increasing or decreasing wealth or mobility, something like that. And this map visualization is accompanied with a story that explains what is going on in the country at the time in which the article was presented. So this is an example of analyze, and within that consume, and within that present. The third thing within the consume block is enjoy. And occasionally you will see folks do visualizations in which, one of the goals is to analyze something, but another goal is that some regular folks may use the tool that you put online and get something interesting out of it, learn something interesting about the world. Perhaps the cultural world is shown on the left. So this is a graph drawing system I put together with my student Jidong Yim in 2009. This is things called Musician Map, and it shows relationships among rock bands, in this case from the late 1960s, but there's no limit. What this thing did was to go off to Audio Scrobbler and another music website to gather the list of personnel of folks who were collaborating amongst the popular music business. And it was very interesting to see the relationships that evolve over time. There's a timeline view to this thing as well. On the right, this thing is called Baby Name Wizard. You can go to that right now if you wish to. And what that does is enables you to explore popular and no longer popular names of that were given to new babies. As they were born. And what this thing does is show the change in popularity of names starting in the 1880s. And the source of this information is United States Census data. Okay, the next segment here under Analyze is in the list of Munzner's actions, aside from consume, is produce. And this might be something that you would do during the course of discovery. It might be something that you do while enjoying or presenting. But in essence, these kinds of activities are things in which the analyst is doing something to the data, adding information to the data collection somehow or other. So let's get to these now. So the first of these is actually listed third in the diagram, and that is derive. And this thing, derive, is fundamental to discovery. And typically what that means is to take some information and transform the view, transform the information in some way. An example of that is to remap the data set with a new visual encoding, or another example of that is to derive new values and attributes by doing operations on the original data. And the example shown in the book is this one here. There's a graph of exports over time, say the foreign trade exports and imports of an individual country, and the blue line indicates imports. The units here is dollars, or probably millions or billions of dollars. And the derived data at the bottom is the trade balance, which is exports minus imports. And what's that simply doing is just taking each time, each month of data, subtracting imports from exports and graphing that derived amount, the sum of that subtraction. So the idea is to transform the data and derive new attributes and values by doing operations on the original data. And you often see that also in the act of aggregation, simplification, or abstraction. That often comes up. You might have, for example, a whole bunch of business sectors in this data up above for imports and exports, and the simplification and abstraction is simply the sum of all exports and the sum of all imports. The other thing that can sometimes happen here in this abstract task is the importing of additional information to derive something new and understand more deeply what is going on in the data set you have. Next, we have record. And the reason why I'm putting this one second, even though it occurs in the middle of the diagram from 2 slides back, is that recording and the next thing that we're going to be showing, annotation, these are things that are a little bit new to the field of visual analytics, And what that really means is that people have been doing this for probably as long as they've been using visual analytics tools, but there has been a new trend over the last 10 years of recognizing this as being important to the task of visual analysis, which is why we're presenting it here. So in the record abstraction, typically one of the things that people want to do is they want to save views, take screenshots, and have visualizations themselves used as an artifact for later use somehow or other. So this thing is taken from the book. It is something called the worksheet history, which is present in Tableau. And what we're doing is just simply showing the steps that were taken in doing analysis. First, we added inventory, then we did a show me on that inventory, then we moved the market size columns around, and then we added the products to columns. And as you can see, as we did that, what happened is we got more details in the bar charts because the product detail created an individual bar for each product. The reason why this is important is that as you're doing analysis, you often are focusing on the question you have at the minute. And one of the drawbacks is because you have a limited amount of short-term memory, you may have forgot how it is you saw something interesting, 10 minutes ago, 20 minutes ago. And so this saving of views and screenshots is very important for managing that kind of information. Next is Annotate, and this will be the last of the produce set. And Annotate really means generating new information on the basis of the information that you've got. In the little diagram that I've shown up above from Munzner's book, we see a little tag saying tag. What that's doing is basically, it's just a visual manifestation of adding information to a visualization that says something more, adds information, what you're thinking about with respect to the data that you're looking at. Okay, and so annotation is typically at the addition of new data, new information about what you're thinking about the data as an analysis, and adding metadata. Maybe you've learned more about how data relates to each other if you've got a new data set that you don't understand well to start with. And adding metadata adds value to the data collection that you can then pass on to the next person doing analysis, or in the act of presenting that, that's something that the presenter will need. One of the things that can typically be useful here is that having annotation capabilities inside the visual analytics toolkit can be very, very useful to be used later. This thing that's shown on the right is something called a dependency graph. This is the recording of the steps of analysis, and I worked on this project with John Dill and Rob Woodbury and a few grad students. And what this thing is doing here is showing the relationships, the steps that we took to do analysis of a data set that was part of a contest for an international conference on visual analytics. In any case, this annotation thing is vital for the analytic journey. It's and the new thing that has come along over the last 10 years is a recognition that creating a place within the visual analytics system is vital, because if you don't do it inside the tool, you're going to do it outside the tool in, say, a set of images, as in the previous slide, or in some text that you're recording elsewhere. And the fact that it's in a separate location means that you could lose it and lose the linkage between the data you're looking at and the thought process that you've engaged in. So that's one of the things that is very important for the analytical journey, is to keep that linkage. At the next level of abstraction, given those 6 abstract goals up top, one of the things you find yourself doing with data is you need to locate or get data. And so Munzner's second level of abstract operations is search. And here in this little table, she shows a 2x2 table in which you either know or don't know what the target is, and you know or don't know where it is located. And so in this little table, we have these 4 terms: lookup, locate, browse, and explore. And each of these is about the act of getting data into the visualization system, into the visual analytics system. And to some degree, Search is as much about data wrangling and data management as it is about what goes on inside a visualization system. But the important point to bear in mind here is that visual analytics isn't just about the art of drawing pictures or the science of finding the right visualization. It's about the entire process of organizing the data and getting it into a form that you can use for an discovery and analysis. And so it's a very important element that is being brought forward in this segment. So the first of these, we'll just do a slide for each one of Lookup, Locate, Browse, and Explore. In Lookup, the target is known and the location is known. And for example, finding a real-life example is to find a book on a shelf. Or another real-life example with a computer involved is to get a student record from a name in Canvas. You all use Canvas, but when I use Canvas, I have all your student records for the individual course. And if I want to find out what grade you got, I need to find your record, and that means I need your name. And because I know what your name is, it's easy for me to find. And so Lookup is a very low intensity kind of task. There's a similarity to retrieve value from lecture segment 4.1, but really we're focused in this abstraction setup from Munzner's book on data wrangling as much as the analytical process. Locate is where you have the target is known, but the location is perhaps unknown. And I'm doing a visual metaphor here with the scatter plot from lecture segment 4.1 and 2. So one of the typical things that you find, again, with student records is, the registrar looks up a name and other, the grades for your courses from the student ID number. And given that I was scatter plotting states, I had states with college degree and median income. I know Kentucky's in that state, in that collection somewhere, but I don't know exactly where it is and exactly what all the data is, so I need to locate it. So slightly more computational work might be present in this kind of task. And that's what's implied here, that the location is unknown. Next is a situation in which the target is unknown. You don't know the actual detailed target, but you kind of know its area. And that is labeled with this kind of fuzzy term, browse. Browsing, in another formulation, is that browsing and search are closely related but not identical things. Browsing is, just as the little table indicates here, where the detailed thing you're actually looking for isn't known, but you know where to look for it. You just need to go to that, that point in the stacks in the library, or you need to go to that shelf in the grocery store. You want to find soy sauce, and you need to go to where the sauces are, but you don't know exactly what brand you're looking for. So in our computational life, browsing is, you do browsing every day, of course, using the browser, hence the term, but also typing in a product category into Amazon is an example of browsing. It gives you, type in vacuum cleaners and it gives you a list, dozens upon dozens upon dozens of vacuum cleaners and all their variations. Another example of that is looking at price graphs in the stock market. So here's an example of recent price graphs for Bank of Montreal, Canadian National Railways, and Emera. And each of these stocks has had some kind of performance over the last few months. But what you're looking for, say, for example, is you might be browsing for a stock that has performed well, or a stock that hasn't had a big dip in price, or some other thing. You don't necessarily know what that stock is, but it's on the stock market. And therefore, you know where to look, but you don't know exactly which one you're looking for. There's a similarity to filter from from lecture 4.1 going on here, where the act of focusing on a subset is at play. In browsing, though, the filtration thing has more of an implication of the location, and you go to that location first before you look at the details. Finally, on this table of 4 items, it is explore, in which you don't really know much about a target, you don't know much about where it is, but you need to know something, and you got to start somewhere. What almost all of us do these days is to use Google, or your favorite search engine if it's not Google. Google a general topic and then go through the frustrating process of recognizing that the topic name you typed in isn't getting you what you want, and then you refine your terms, and eventually you get to the point of understanding a little bit about the domain you're working with. So recently I've been in the market for a new PC, and I used to have a vendor that I used to go to, NCIX. They went out of business, and so I need to find somebody new. And I know I don't want to use Dell, because if you buy a Dell, you can't do anything with it once you've bought it. So anyway, never mind about Dell. But my point is that that exploration process, you know, I know PC. That's it. That's what I know. I don't know who the vendors are, because I had a vendor and they went bust. So what I need to do is explore the domain of people who sell computer hardware in the PC mode. If I wanted an Apple computer, I know exactly where to go. I just go to Apple's website. Another example that's actually given in chapter 3 is to look for outliers. And so I've just drawn a circle around the outlier from a graph from a previous lecture, exploring a data set upon data set and looking for outliers or weird things, anomalies, or finding out what general behaviors are amongst this data collection that you've got is the kind of thing you would expect while doing exploration. Right. So now that we've kind of talked about search and known and unknown targets and locations, a more detailed version of this stuff is query. And it's in this part of Munzner's actions categories where we get closest to the kinds of task descriptions that we spoke about in in lecture segments 4.1 and 4.2. So the query means once we have found the things of interest, we carry out queries on them and about them. So there's less of in query, there's less of a flavor of data wrangling, and we do have a data set that we know what's going on, and we need to focus on the details of what's going on in that data set. And so often it is defined, the act of doing querying is defined by the scope of the prior work or the higher level, more abstract work that has been depicted in the previous slides. So in this map of Canada on the right, this was the results of the 2011 federal election. And if we want to do query to identify and want to identify a single target, you know, here's the entire map with all the federal ridings, and we want to get a sense of what the how the election turned out for an individual riding, and that is an example of the identify action. If you have multiple targets, often what you do is you want to do things like comparing between each of the targets that you may gather up. And finally, if you have all the targets, so to speak, of give me all the data within this data wrangle collection, then you often want to do summarization, and we'll speak to more of that stuff in detail. So in this situation, within the query identify task, what you're doing is querying that yields, you know, a few targets. One or two is what I say here in the slides. And this is equivalent to retrieve value from lecture 4.1. I recognize that search, where you know the location, search lookup is very similar to this, but here the query identify task is much more closely linked to doing identification and retrieving value within a visualization tool. Remember that sections 4.1 and lecture segments 4.1 and 4.2 focused on tasks done within a visualization tool, and query identify has a similar context. So in this case, we are showing another stock market graph. The data has been wrangled, and now you want to analyze a data case. And this is some stock, I can't remember which. And what I've done is hover my mouse on the timeline, 1 in the afternoon, and got a price that was the stock was sold at that time, and you know the close was $54.57. Next is compare, and typically what you're doing is doing some querying that yields a subset of all the targets, equivalent to filtering from lecture 1. And this example that I'm showing here is you've identified bank stocks out of the stock market collection, and now you want to compare their performance. So here we have BMO, which was in a few slides ago, and CIBC, and you want to compare their price performance over the preceding 3 months. And so this is BMO's prior 3 months, and this is CIBC's prior 3 months, and you might be interested in the active comparison. They're overall similar shape, but there's a big, sort of abrupt increase in price for BMO. The price increase was present in CIBC, but there was a drop, and it would be interesting to investigate why BMO dropped at that time and CIBC did not. And that comparison is intended to highlight such differences in performance over time. Finally, query summarize is a querying that yields all the targets, and summarize encapsulates pretty much all of the descriptive statistics. And these are similar to the tasks that we talked about in lectures 4.2. So, for example, compute derived value, determining range, finding extremum, characterize distribution. Each of these things are acting in a way to summarize what's going on in the data collection. And according to Munzner's taxonomy that we have here, this summarization activity is intended to bring together all those types of activities whose job it is to summarize all the data that you've got. Okay, so that has been the list of targets, of actions that you could do, starting with the most abstract, things like discover and present, working towards the most detailed, things like querying, summarizing, and so on and so forth. Targets is really about the data and the visualizations that you might do on the data. And to replay our diagram from lecture 2.1, this is where the domain of targets lives. And if you recall, the purpose of this diagram is to show the pipeline of information from raw information that is being gathered from a data wrangling exercise to a data which is transformed to a data set, which has been visually mapped to a visual form, which has been transformed into views. Each of these boxes is about data. And the dotted line around these things is meant to indicate what Munzner is referring to as targets. So targets, she points out, are the nouns of the data activity that you're intending to do. And I'm just going to briefly recap this stuff, mainly because we've spoken at length of these types of activities, and we'll speak about more of this stuff as we move forward in the term. So one of the things that you are interested in is, if you're talking about all of the data together, you're interested in trends, in behaviors that might be exhibited by the data collection, also outliers that we have spoken about a few times, as well as features in the data. Let's say a feature in the stock market data that we showed is significant price increases or decreases during a short period of time, or perhaps price increases or decreases possibly indicating some improvement or worsening of the company's performance over time, and you're interested in that in order to maintain the value of your investment and hopefully make some money. On the right here, we have some focus on the attributes, and this is an individual variable, and we have the familiar terms, once again, of getting a sense of the distribution, finding the extremes, so there's the find extreme value, finding if there's some kind of dependency from one to another, finding a correlation, and finding if there's similarity between one graph, one subset of the data, and another. So each of these things we've spoken about at some length in lecture segments 4.1 and 4.2. We are not going to talk too much at this point about network data and spatial data. We're really going to focus on non-spatial, non-network data for a significant, for pretty much the first half of the term, but we will get once again to discussions of network data later on in the term. Okay, so that's it for lecture segment 4.3, visualization tasks.